Hi, in this video, it's about miscellaneous plots. We will cover 4 different plots, which are a little bit less common to the other plots that we have used, but still they are very useful in some specific scenarios. So just remember the type of question that you need to answer, where you're going to pick a visualization. So you need to answer like, okay, you need to ask yourself, what is the goal of the visualization? What do you want to capture? Do you want to compare values? Do you want to present or analyze the distribution of your data? You want to kind of like identify if there are some relationships, like a linear or non-linear relationships, track trends. It's also important, of course, the type of data that you have, the dimensionality, how many variables are involved. This is just a guide. This is not like the final guide, but at least will give you an idea of which are the possible analysis. Again, this is not like a fully comprehensive chart, but it gives you at least kind of like an intuition of what are the questions that you need to ask and what are the basic charts that at least you should master. Okay, so the first question is, what would you like to show? So here we have 4 options. You want to check distribution of your data, comparison, relationships, or composition. If you want to analyze distribution, then the alternatives here, the suggested are histograms, density plots. In that way, you can kind of like identify the shape of the distribution of your data. Now you want to compare. So here you will have then bar charts in the different variations, like stack bar charts, group bar charts, also line charts. They are possible if you want to compare like multiple time series, for example. That's a case. All right, so if you want to understand and check relationships between two variables or among different variables, then you have scatter plots for sure. Remember the pair plots where you analyze like every single pair of variables. So that's kind of like the standard. If you remember from our previous sessions, we also use mosaic plot for categorical variables when we have like a two-way table, that contingency table. That's another alternative. And of course, for composition, you can analyze pie charts, stack bar charts, or there are some area charts where you can show the levels, the contribution uh, for each categorical variable. Okay, so these are some of the ideas. However, there are more options. So this is the first plot that we're going to cover today, the radar or spider plot. This one is very common when you're kind of like analyzing multiple dimensions, multiple variables. So typically it's used when you have more than 3, less than 10 or 8. So this is an example in sports. So we're analyzing a player in baseball. We're checking 5 dimensions or 5 variables of the performance of this specific player: hit average, speed, throwing, defense, and hit power. So this is very common in some games, sport games. Typically, there are the different attributes per player. Also, I have seen in different games like RPG games where there are some characters and they fight. So there is like the attack, defense, magic spells. So there are different dimensions to measure the how good they are, right? So with the spider plot, you can see the performance of these characters. Now, also in business, when you are assessing, let's see, like how good is a company in terms of artificial intelligence, like AI maturity level, there are different drivers. For example, how good they are storing data, how good or how prepared are the human resources in that company to analyze data. And there are different dimensions and leadership, like also for the like from the management perspective, how invested they are, like how much do they trust these technologies. So there are different dimensions, and then you can use a spider plot to show, the values for each dimension, and it gives you an idea of how good or how bad is the current performance. So there are multiple applications with the radar plots. Let's go to Colab. There is a notebook. In the notebook, we will check two examples. The first one is simple. We're going to compare two countries, USA and Germany. Um, there are five metrics here, or dimensions: GDP, health, education, defense, and tech. So using a spider plot or radar plot, we can compare their performance. So for example, in GDP, USA is showing like a better performance, but in terms of health, education, it's a lower performance, right? And same thing, same idea with the tech and defense. So again, this is a good way to do some benchmarking or yeah, comparisons in general. Okay, there is one more example here. I highly encourage you to practice it. I'm using here Plotly Express PX for the radar chart. So in the in-class activity, we're going to compare three sports: track, swimming, and gymnastics. And there are five dimensions: speed, strength, endurance, agility, and flexibility. So there are some questions like which sport emphasizes more flexibility, which is the most balanced profile. So with the information for each sport, for track, swimming, and gymnastics, we can create our radar plot. So here you have the performance. Let me show you the labels. Okay, here. So which sport requires the like flexibility the most? Of course, it's going to be gymnastics, right? You see the difference here. Now, to answer questions like which is like more complete. So in the case of gymnastics, we can discard it because if you notice, it's really good with flexibility and agility. But if you check the other dimensions, is the like the worst performance compared with the other, with the other two. For example, the speed, the rank is the third one. Strength, it's also the worst, and same thing with endurance. Okay, and now which one is more complete? Then the fight will be between track and swimming. Both have like a more they require like when we compare these three, they have like a more balanced performance, because if you check the ranking, for example, track is really good, you require speed, right? But then in the other dimensions, they are kind of like in the second place. So it's kind of like the same thing with swimming. Same thing with swimming. If you check swimming, in the case of swimming, we have here the red one. In speed, they are the second. Strength, they are the first. And endurance, they are the first, right? But in the others, they are also second. Yeah. So any of those two will be a good answer. All right. So let's continue with the different plots. So this was number one. This one is a little bit more basic and simple, the waffle chart. When do we use this one? You will see them typically in a dashboard, especially when there is like a metric, a number, and you wanna kind of like visualize the number just to give an idea to the audience. Also in some infographics, it's very common. So for example, here we have four waffle charts. Um, in each waffle chart there are like 100 parts. So each point that you see inside the waffle chart is like 1%, right? So then this is like a survey, and each question is like a yes or no question. So you have like which percentage, what percentage of the respondents say yes or no, and that's how you get this number. Also, we can use waffle charts to show like project completion status, like for different activities. You can kind of, okay, it's at 50%, 70%, and you can kind of like visualize that progress, in the waffle chart. Again, this is a basic waffle. It's more for the audience to kind of like visualize the number in a different way. But you won't find here like a pattern or something different when we like compared to other plots. So let's check a couple of examples. So here we have a survey, and there are two questions. Do you prefer coffee or tea? Are you a morning person or a night person? There are two questions here. We know the answers of the respondents. Like we have 60-40 and 45-55, and we can create then our waffle charts. This is for coffee and tea. So most of the respondents, they prefer coffee, right? You can see that in the waffle chart. And here for the morning versus night, you see that night it's higher, right? In the second problem, for waffle charts, here what it's this for to analyze the completion of activities, tasks in a project. So there are four different activities, and we have the current status, like 80% completed, 50% completed, and then we can create for each of these activities, we can find a waffle chart to visualize the progress. So again, this is just it's simple. It will show you like a special pattern. So this is for the front end progress. So there's a high level of progress here. Back end is like in the middle. API right now it's small progress, 30%. Documentation is slightly above the middle, right, above 50%. Okay, let's see a less common plot. I think even for me, I haven't used this one before. It's a ternary plot. This one is when there are three variables. That's very restrictive, it's very specific. And also, the three variables, when you add them up, they have to be equal to 100%. So it's for composition. So typically, you will find these ternary plots in geology, chemistry, they are common. But also in businesses, it's possible to adapt them. So, for example, in this figure that we have here in the slide, you see, okay, there are three variables. The chocolate level from 0 to 100, the right side, sugar level from 0 to 100, the level of milk, the percentage of milk. So depending on the composition, then you will get different products, right? So the way that typically these ternary plots are used, it's not like it's not about like plotting individual points. You can do that, of course, but mainly they try to identify areas. Okay, like maybe in the upper area of the triangle, you will find products with these properties, with these characteristics. Same thing, like so identify different regions. So if a point, an observation is located in that region, then you can kind of like generalize what is the composition of that observation. So that's typically the way they use it in geology. Is that okay, if the soil has these properties, or if it's located in this area of the triangle, then typically belongs to this type of soil. Things like that. That's how they use it. Again, it's not like point by point analysis. It's more about identifying like a region inside the triangle or the ternary plot. So let's check a couple of examples in our collab file. I'm going fast and not getting into details of the code because it's given, right? I will give it to you, and you will find it. You will find the link below this video also. Okay, so here the first one is for market share. So we have three companies: company A, B, and C. These are our variables, and we have three regions: North America, Europe, and Asia. The market share for a cell phone company, for three cell phone companies. For example, in the North America market, company A has 60% of the market, company B 30%, and company C 10%, right? That's the idea. Then for Europe, same idea, and Asia. Okay, this is what we get. So here the variables are the company shares, and each point is each market. So let's see this one that is on top of the other points in the North America market. So sometimes it's challenging to analyze one point. So for example, here, what interpretation of this North America market? Okay, so the company A is you have to make like draw a horizontal line. So company A, it's 60% the market share here, you have it right there, right? Now for company B, the market share is 30%. How do I get that? Because now I have to move in parallel these lines here, and I get to the point 3 here. This is for company B, the 30%. That's where I get that. Now for the market share of company C in that North America market is 10%. So I have to move again the parallel line here in the triangle to that axis, and here is the point one. That's how I get that. So again, it's a little bit more challenging when you're analyzing like one point, but the idea is to identify areas. For example, in the upper triangle here, in the upper side of the triangle, is where company A has a high share, right? And the other companies they have like a very small participation. So things like that. That's how you can use this type of plots. Let me show you another example. This is for food composition. So we have three dishes here: pasta bowl, grilled chicken, and avocado toast. And we are analyzing three components: carbs, protein, and fat. We have the percentages. Again, remember that for the ternary plot, we need the composition. When we add this variable, they have to be equal to 100%. All right. So when we plot that, so we get our triangle. So here in the upper side is where we have a, like food that with high carbs, high number of carbs. So pasta bowl is here on top of, like the other points. Now in the lower side, going to the left, it's more like protein rich products, right? So in this area is where we have like high protein products. If you have a steak, for example, it will be for sure in this triangle. Maybe eggs also, right? You will find them here. So again, more the idea here is not to like plot individual points. It's more about finding regions. Okay, like typically products that are here, they are like good for you. You have to be careful maybe with products that are very high here. I'm not an expert in nutrition, but just to give you an idea of the type of applications. You can analyze this. All right. Let's check our last plot in this video. This one is very useful. The Hexbin plot. I really like this one. It's simple. The thing is that in some cases, when you have large data sets, the problem with the large data sets is that you have some overlapping of your observations in a scatter plot, and it is difficult to identify a pattern just by looking at the plot when there are too many observations. So for example, if we get this plot, the first one, so there are a lot of observations and it's difficult to see a pattern. Now, in the Hexbin plots, what it does is that first it splits the visualization in hexagons, right? And then it assigns a color. So if the color is light, like almost white, it means that the number of points inside that hexagon is small. Now, if there are a lot of points inside that specific hexagon, then it's going to be darker, right? So that's the idea of this color. It's like a heat map, right? Now, the good thing about that is like now you kind of like get rid of the noise and you can see a pattern here. You can see, for example, here three groups or three clusters, which initially they were not that clear in the scatter plot. So the Hexbin plot is useful when you have a lot of large data sets. Okay, let's go to the example. There are two examples in our notebook. In the first one, it's for a city. Our observations are locations of vehicles throughout the day. We have 320,000 observations in that data set. And the purpose of the analysis is to identify some hotspots, for traffic and maybe, make some decisions to improve the mobility. Okay. So when we plot the original data set using this is a scatter plot. So you see, like there are points everywhere because there are 320,000 points in a single chart. So it's difficult to spot patterns here. But now, when you use the Hexbin plot, now you can see, like, okay, the density is higher in these two spots. It means that there are a lot of vehicles in those two specific points at 40-40 and 60-60. So, of course, the authority should focus their attention in those points. So that's how you can use the Hexbins, right? It's like to find patterns when we have a lot of data, large data sets. Something important is that with the Hexbins, it's difficult to identify outliers or the typical data because those are like low density areas, so it's difficult to see them here. Now you check the scatter plot, it's possible to see the outliers here. You see this, small points here, right? But in the Hexbin, it will be difficult to spot them. So yeah, the Hexbin is not designed to spot outliers. It's designed to find patterns, right? In congested areas in your plots. Okay, this is the last problem. In this one, it's about a test that we're analyzing for 50,000 students. So the test it has two sections: multiple choice and open-ended questions. We want to kind of like analyze the performance of the students in the in the two sections, in the multiple choice and the open-ended questions. So we visualize the performance of our students. Again, it's not clear. It's not clear. Maybe in this one it's a little bit more clear compared to the previous one. But yeah, it's not that easy to spot the pattern here. But now if we use the Hexbin, so you see that there is a higher concentration. There are like three regions, right? So here in the middle, you see this like big circle where we have students with a balanced performance. They are doing fine in both sections. By fine, I mean between 60 and 80, right, percent in both sections. Now there are in this circle here to the left and this one to the right. In these specific groups is we have students that they did really good in one section and not that good in the other section. So it's higher than 80 in one section, but less than 60 in the other section. So that's how you can use again these exhibits to find these patterns. Remember what I told you, I won't use them to identify outliers because here we have. And actually there is a mistake. If you notice, I mean, there are some points here, they are fine because it's like students that got less than 20 in the x axis, right? That's possible. But here, this is the error. If you notice, these points here to the right, they are not possible. I mean, of course, it depends on the context, but in this specific context, they shouldn't be possible. It means that the students with a grade higher than 100. That's possible if you have, like a bonus, but that's not the case. Here, what's happening is because we're generating data, with a random generator, like a normal distribution, and the normal distribution, even though you define set like a mean value and standard deviation, it theoretically speaking, it can go from minus infinity to infinity. So it is possible to get outliers, big numbers. That's possible, and that's what we're getting here, like a number above 100. But we can fix that. I just wanted to point out that you can spot that here in the scalar plot, but it's more difficult to see that here in our Hexbin plot. Okay, I'm gonna stop the video for now. I'll see you in our next lecture.